Programming can be complex. When you first start writing code, it might seem straightforward, just a few lines here and there to get your computer to do what you want. But as you continue to build more features and add more logic, your code base can quickly become overwhelming. Suddenly, you're juggling dozens or even hundreds of lines of code, and it becomes difficult to keep track of what each part does. As programs grow larger, they become harder to manage. You might find yourself copying and pasting the same code in multiple places, or struggling to fix a bug that seems to pop up everywhere. This can lead to confusion, errors, and a lot of wasted time. Without a clear structure, even the simplest tasks can become daunting, and making changes can feel risky. This is where functions come in handy. Functions are like your personal assistants in programming. They allow you to group related code together, give it a name, and use it whenever you need it. Instead of repeating yourself, you can simply call a function, knowing it will do exactly what you expect every time. Functions are the building blocks of C programs. They help you organize your code into logical sections, each with a specific job. By breaking your program into smaller pieces, you make it easier to read, test, and maintain. This modular approach is essential for writing reliable and scalable software. They help us break down complex tasks into smaller, more manageable pieces. Imagine trying to solve a giant puzzle all at once. It would be nearly impossible. But if you focus on one section at a time, the task becomes much simpler. Functions let you tackle programming problems in the same way, by dividing them into bite-sized chunks. When you use functions, you can focus on solving one problem at a time. You can write a function to handle user input, another to process data, and yet another to display results. Each function does its job, and together, they form a complete program. Think of functions like tools in a toolbox. Just as you wouldn't use a wrench to drive a nail, you wouldn't use a function designed for one task to do something completely different. Each tool has a purpose, and so does each function in your code. Just as a screwdriver has a specific purpose, so does a function in C. For example, you might have a function that adds two numbers, another that sorts a list, and another that prints a message to the screen. Each one is designed to do its job efficiently and reliably. You wouldn't use a hammer to tighten a screw, and you wouldn't use the print function to calculate a sum. Choosing the right function for the right task keeps your code organized and prevents mistakes. It also makes your intentions clear to anyone else reading your code. When your code is organized into functions, it's easier for others to understand what each part does. This is especially important when working in teams, where clear communication and structure can make or break a project. Each function has a designated task, making your code cleaner and easier to understand. By mastering functions, you'll be able to write code that's not only powerful, but also elegant and maintainable, no matter how complex your programs become. Imagine you're building a house. You start with a vision, a plan, and a set of goals for what you want to achieve. But as you look at the empty lot, you realize just how many different parts and pieces are needed to bring your idea to life. There are walls, doors, windows, plumbing, electrical systems, and so much more. If you tried to create every single component from scratch, not only would it take an enormous amount of time, but you'd also risk making mistakes and ending up with a less sturdy, less reliable house. You wouldn't build every single part from scratch, would you? Instead, you'd use materials and components that have already been designed and tested, like pre-made doors, windows, and even entire wall sections. These prefabricated parts are reliable, efficient, and save you a huge amount of effort. They let you focus on the bigger picture, like the layout and design of your home, rather than getting bogged down in the details of every single nail and screw. You'd use pre-built doors, windows, and maybe even prefabricated walls. These ready-made elements are designed to fit together seamlessly, making the construction process faster, more efficient, and less prone to errors. By relying on these components, you can build a stronger, more reliable house in less time. Functions in programming are similar. Just as you use pre-built parts in construction, programmers use functions as building blocks for their code. A function is a set of instructions that performs a specific task, and it can be used over and over again wherever that task is needed. This approach saves time, reduces errors, and makes your code much easier to manage. They are pre-built blocks of code that perform specific tasks, saving you time and effort. Instead of rewriting the same code every time you need to perform a common operation, you simply call the function. This not only speeds up your workflow, but also ensures that your code is consistent and reliable throughout your project. Functions make your code more organized by dividing it into logical sections. When you break your code into smaller, manageable pieces, it becomes much easier to understand and maintain. Each function has a clear purpose, and you can quickly see how different parts of your program work together. This organization is especially helpful as your projects grow larger and more complex. This makes it easier to find and fix errors. If something goes wrong, you can quickly pinpoint which function is causing the problem, rather than searching through hundreds or thousands of lines of code. Debugging becomes less stressful, and you can resolve issues faster, keeping your project on track. Furthermore, well-written functions are reusable. Once you've created a function that works well, you can use it in other parts of your program, or even in entirely new projects. This reusability is like having a toolbox full of reliable, ready-to-use tools that you can count on whenever you need them. Once you write a function to calculate the area of a circle, for example, you can use it again and again without rewriting the same code. This not only saves you time, but also helps ensure that your calculations are always accurate and consistent. In short, functions are essential tools that help you build better, more efficient, and more reliable programs. Just like using the right building blocks helps you construct a better house. In the world of programming, one of the most fundamental building blocks you'll encounter is the function. But what exactly is a function, and why is it so important? In simple terms, a function is a group of statements that are bundled together to perform a specific task. Think of it as a mini program within your larger program designed to do one job and do it well. Functions help us organize our code, make it reusable, and keep things neat and tidy, especially as our programs grow more complex. Imagine you have a big project to complete, but you can break it down into smaller, manageable tasks. Each of these tasks can be thought of as a function. For example, just like a person at a desk might have the specific job of stamping letters, a function in your code might have the job of adding 2 numbers, sorting a list, or displaying a message on the screen. To make this idea even clearer, let's use a real-life example that most of us are familiar with: a coffee machine. When you want a cup of coffee, you don't need to know exactly how every part inside the machine works. You just need to know what to put in, what button to press, and what you'll get out. You start by putting in coffee beans and water, then you press a button. After a short wait, the machine gives you a hot, fresh cup of coffee. You don't have to worry about the grinding, the heating, or the brewing process. The machine handles all of that for you. In programming, a function works in a very similar way. You give it some input, just like the coffee beans and water. These are called arguments. The function then processes this input, following the instructions you've defined inside it, much like the coffee machine follows its internal steps to brew your drink. Finally, it gives you an output, which is called the return value. This could be anything from a number, a word, a list, or even something more complex. The input you provide to a function, those arguments, are like the ingredients you put into the coffee machine. The output, or return value, is the finished product you get back. This clear separation of input, process, and output makes functions incredibly powerful and easy to use. The real magic happens inside the function, where the actual work is done. This is where you define exactly how the task should be performed step by step. By using functions, you can write code that is easier to read, test, and maintain. And just like you can use the coffee machine over and over again, you can call a function as many times as you need, whenever you want to perform that specific task. A function in C has a specific structure. It consists of 3 main parts: the function declaration, the function definition, and the function call. The function declaration, like a blueprint, tells the compiler about the function's name, the type of data it returns, and the type of data it accepts as input. The function definition is the actual code that performs the task. Finally, the function call is where you use the function in your main program. Before you can use a function, you need to declare it. A function declaration is like introducing yourself to someone new. You tell them your name and a bit about yourself. For example, you might write int add int a, int b. In this example, we are declaring a function named add. The int at the beginning tells the compiler that this function will return an integer value. The part in parentheses, int a, int b, means the function expects two integers as input, represented by a and b. The function definition is where you write the actual code that the function will execute. It's kind of like explaining what you do for a living after introducing yourself. So in C, you might write something like this. Int add int a int b, int sum equals sign a plus b, return sum. Here, the add function takes two integers, a and b, adds them together, stores the result in the sum variable, and then returns the value of sum. Once a function is declared and defined, you can use it in your main program. This is called calling a function. For example, int main, int x equals sign 5, y equals sign 10, int result equals sign add x, y. Printf, the sum is %d result, return 0. In this example, we call the add function with x and y as input. The function calculates the sum and returns it, which is then stored in the result variable. Finally, we print the result. C provides a set of ready-made functions, like printf for printing output and scanf for taking input. These are called built-in functions. You can use them directly in your code without defining them. However, you can also create your own functions, tailored to your specific needs. These are called user-defined functions. The add function we created earlier is an example of a user-defined function. Using functions makes your code more organized, reusable, and easier to debug. Just imagine trying to find a single error in 1,000 lines of code versus finding it within a 20-line function. Moreover, functions promote code reusability. You can use the same function multiple times in your program or even in different programs, saving time and effort. This modular approach to programming makes your code more manageable and efficient.